New certification practice content is released every week. Subscribe to stay current and visit cloudcertificationstore.com for weekly releases and complete practice ebooks. This episode continues the complete video playlist for the AWS Certified AI Practitioner, AIF-C01. You're on episode 7 of 15, covering questions 61 through 70. Let's keep going. Question 61. A manufacturing company wants product descriptions in multiple languages. Which AWS service automates this? Option A, Amazon Translate. Option B, Amazon Transcribe. Option C, Amazon Kendra. Option D, Amazon Polly. The correct answer is A, Amazon Translate. Explanation. Translate performs neural machine translation for many language pairs. It can run batch or real-time to scale across catalogs. Quality can be customized with parallel data or terminology. It precisely meets multi-language text needs. Why not option B? Transcribe speech to text. It doesn't translate written descriptions. Different modality and purpose. Not applicable. Why not option C? Kendra Enterprise search over documents, not translation. It won't generate localized text. Misaligned to requirement. Why not option D? Poly text-to-speech. It vocalizes text, not translated. Useful for accessibility, not localization. Therefore, incorrect. Question 62. A firm is adopting Amazon Q Business and needs centralized workforce user management for dashboards/reports. What should they use? Option A, AWS IAM service. Option B, AWS account. Option C, IAM Identity Center. Option D, IAM user. The correct answer is C, IAM Identity Center. Explanation. Identity Center provides centralized workforce identities and SSO across accounts and apps. It's the recommended way to manage user access for SaaS-like AWS applications. It supports SIEM, identity providers, and fine-grained permissions. This aligns with secure, scalable user governance. Why not option A? AWS generic IAM is foundational but intended for AWS principles and machine access. It's not the preferred workforce SSO hub for business apps. Managing users here scales poorly vs. Identity Center. Hence, suboptimal. Why not option B? AWS account a billing and isolation boundary, not an identity system. It cannot assign or federate user identities. Confusing scope leads to poor access control. Not applicable. Why not option D? IAM user legacy per user principles inside IAM lack centralized SSO/federation features. Hard to scale and audit across many apps. Identity Center supersedes this pattern. Therefore, not recommended. Question 63. A contact center wants insights from customer call audio. What should they do first? Option A. Build a conversational chatbot with Amazon Lex. Option B. Transcribe call recordings with Amazon Transcribe. Option C. Extract information with Amazon SageMaker Model Monitor. Option D. Create classification labels with Amazon Comprehend. The correct answer is B. Transcribe call recordings with Amazon Transcribe. Explanation. Transcribe converts audio to text, creating a substrate for downstream NLP. Once text exists, you can apply Comprehend for sentiment/entities or Bedrock for summaries. It's the necessary first step in an audio analytics pipeline. This unlocks search, CA, and trend mining. Why not option A? Amazon Lex useful for real-time bots, not post-call analytics. Lex won't process recorded audio for insight extraction. It addresses a different stage, live interaction. Hence, not first. Why not option C? Model monitor monitors drift/quality of your models, not analyze audio. It requires an existing model endpoint. It doesn't convert speech to text. Therefore, irrelevant. Why not option D? Comprehend powerful for text, but you must produce text first. Feeding raw audio to comprehend is impossible. Transcription precedes NLP. Thus, D is premature. Question 64. A company has petabytes of unlabeled customer data and wants to tier customers for campaigns. Which learning type? Option A, supervised learning. Option B, unsupervised learning. Option C, reinforcement learning. Option D, AIF. The correct answer is B, unsupervised learning. Explanation. Clustering e.g. K-means hierarchical discovers natural groupings without labels. It's suited to segmentation when ground truth tiers don't exist. You can post-label clusters to create tiers for activation. This matches the data and objective perfectly. Why not option A? Supervised requires labeled tiers which the company lacks. Creating labels at petabyte scale is costly and slow. Unsupervised discovery is more practical here. Hence, not suitable. Why not option C? Reinforcement learning targets sequential decisions with rewards, not static segmentation. No clear environment or reward is defined. Adds complexity without benefit. Therefore, incorrect. Why not option D? RLHF needs human feedback labels and is used for aligning generative models. It doesn't solve unlabeled segmentation at scale. Misfit for the task. Thus, wrong choice. Question 65. An AI practitioner needs a search app that handles queries with both text and images. Which model is appropriate? Option A, multimodal embedding model. Option B, text embedding model. Option C, multimodal generation model. Option D, image generation model. The correct answer is A, multimodal embedding model. Explanation. Multimodal encoders map text and images into a shared vector space. This enables cross-modal retrieval, e.g., image left-right arrow text similarity via KNN search. It supports scenarios like find manuals matching this photo or find images matching this caption. It's purpose-built for multimodal search. Why not option B? Text embedding model encodes only text, cannot embed images, limits you to text-only queries and documents, fails the multimodal requirement, thus insufficient. Why not option C? Multimodal generation model creates content, e.g., images from text, but isn't optimized for vector search. You still need embeddings and an index for retrieval. Generation adds cost without solving search. Therefore, not ideal. Why not option D? Image generation model produces images from prompts or edits. It doesn't embed or search. Offers no similarity indexing for retrieval tasks. Misaligned to search functionality. Hence, incorrect. If you want more practice like this, subscribe for weekly certification videos and guides. Preview weekly releases and complete practice ebooks at cloudcertificationstore.com. Question 66. A company uses a foundation model, FM, from Amazon Bedrock for an AI search tool and wants to fine-tune it with the company's data. What must they provide? Option A. Provide labeled data with the prompt field and the completion field. Option B. Prepare the training dataset as a TXT file that contains multiple lines in CSV format. Option C. Purchase provision throughput for Amazon Bedrock. Option D. Train the model on journals and textbooks. The correct answer is A. Provide labeled data with the prompt field and the completion field. Explanation. Fine-tuning requires structured examples that map an input prompt to the desired completion, so the model can learn target behavior. JSONal with prompt. Completion is the common format for supervised tuning. This enables reproducible training and evaluation across batches. It aligns with Bedrock's fine-tuning expectations for many text FMs. Why not option B? TXT/CSV lines. A flat text/CSV file lacks explicit prompt completion pairing in the required schema. Parsing ambiguity can break training pipelines and labels. Even if convertible, you'd still need to restructure to JSONal pairs. It's not the correct input format. Why not option C? Provisioned throughput PT reserves capacity for predictable latency/throughput. It doesn't supply training data or enable tuning by itself. You can fine-tune without PT and you can buy PT without tuning. It addresses performance, not data format. Why not option D? Journals and textbooks. Generic corpora may be off-domain and lack supervised target completions. The goal is to align to your use cases, not encyclopedic knowledge. Unlabeled text won't teach task-specific outputs reliably, thus not suitable. Question 67. A law firm wants an LLM application that reads legal documents and extracts key points. What should they build? Option A. Automatic Named Entity Recognition (NER) system. Option B. Recommendation engine. Option C. Summarization chatbot. Option D. Multi-language translation system. The correct answer is C. Summarization chatbot. Explanation. A summarization chatbot can condense long legal texts into concise bullet points or briefs on demand. You can specify tone, neutral/legal, structure issues, holdings, rationale, and length. Retrieval can ground responses in the document to reduce hallucinations. This directly fulfills extract key points in a user-friendly way. Why not option A? NER identifies entities, people, orgs, statutes, but not the key arguments or rulings. It may be a helpful subcomponent, yet it doesn't produce full summaries. You'd still need a summarizer for actionable insights, so it's insufficient alone. Why not option B? Recommendation engine recommenders rank items. They don't read documents and extract content. There's no user item matrix here to personalize. It's the wrong paradigm for legal analysis. Hence, misaligned. Why not option D? Translation translates text across languages but doesn't summarize or prioritize points. It's orthogonal to the requested capability. Unless multilingual is needed, it adds cost without benefit. Therefore, not appropriate. Question 68. An AI solution must detect whether an IP address is suspicious to protect an application. What should they develop? Option A. Speech recognition system. Option B. Named entity recognition system. Option C. Anomaly detection system. Option D. Fraud forecasting system. The correct answer is C. Anomaly detection system. Explanation. Anomaly detection models learn normal traffic patterns and flag deviations, e.g., abnormal GOs, bursty requests. They work with streaming telemetry and can adapt to seasonal patterns. This directly supports IP risk scoring without labeled attack data. It's the standard approach for early threat signals. Why not option A? Speech recognition converts audio to text. There's no speech here. It cannot evaluate IP behavior or traffic characteristics. Entirely unrelated to network telemetry. Not applicable. Why not option B? NER extracts entities from text, not anomalous patterns from numeric/time series data. IP risk is a behavioral problem, not a token classification one. Using NER would produce no useful signal. Thus, incorrect. Why not option D? Fraud forecasting typically targets transactional outcomes with labels, fraud/not fraud over time. For network IP risk, supervised labels may be sparse and slow. Unsupervised/semi-supervised anomalies are a better first line. Therefore, D is not the right fit. Question 69. Which feature of Amazon Open Search Service enables vector database applications? Option A. Integration with Amazon S3 for object storage. Option B. Support for geospatial indexing and queries. Option C. Scalable index management and nearest neighbor (KNN) search capability. Option D. Real-time analysis on streaming data. The correct answer is C. Scalable index management and nearest neighbor (KNN) search capability. Explanation. OpenSearch's KNN plugin stores high-dimensional vectors and performs similarity search efficiently. It supports distance metrics, cosine/L2/IP, for embeddings. Combined with filters, it powers hybrid semantic plus keyword retrieval. This is foundational for RAG and recommendation use cases. Why not option A? S3 integration useful for snapshots and ingest, but not sufficient for vector search. Object storage doesn't provide ANN indices or distance search. You still need KNN capabilities in the engine. Therefore, not the enabling feature. Why not option B? Geospatial queries targets lat/long data with spatial indices, unrelated to general embedding spaces. Geospatial and vector similarity are distinct indexing strategies. Geospatial won't solve semantic nearest neighbor search. Hence, incorrect. Why not option D? Streaming analysis while OpenSearch works with streams e.g. via Kinesis. Streaming alone doesn't create a vector DB. You still need vector fields, indexes, and ANN search. So streaming isn't the vector feature asked for. Question 70. Which is a valid use case for generative AI models? Option A. Improving network security with intrusion detection. Option B. Creating photorealistic images from text for marketing. Option C. Enhancing database performance with optimized indexing. Option D. Forecasting stock market trends. The correct answer is B. Creating photorealistic images from text for marketing. Explanation. Text-to-image diffusion models produce novel visuals from prompts, ideal for creative campaigns. They can be steered with style keywords, negative prompts, and CFG scale. This reduces dependency on stock photos and accelerates iteration. It's a core generative capability. Why not option A? Intrusion detection, predominantly anomaly detection or supervised classification with logs, not content generation. Generative models can synthesize data but don't detect intrusions directly. It's the wrong tool for security monitoring. Thus, misaligned. Why not option C? Database indexing, a systems engineering task. GAIs don't restructure B-trees or query planners. Gains come from DB configuration and workload design, not text/image generators. Generative models don't optimize indices. Therefore, unrelated. Why not option D? Stock forecasting time series modeling needs predictive algorithms, stat/ML. Generative content models don't inherently produce calibrated financial forecasts. It's a separate discipline with different metrics and risks. Hence, not appropriate. Another practice set complete. Follow the channel to stay connected with future certification content and share this playlist with anyone preparing for the same exam. We'll continue in the next episode.